Okay, back to 10.2. If P is 1 on the P series, it's called a harmonic series. And that's the one that diverges, okay? But if P is greater than 1, so this is what we're going to, this is our P series test. If P is greater than 1, it converges. The P series does. If P is between 0 and 1, it diverges. If P equals 1, it diverges. That's called the P series test. So for example number 3, determine whether the following series converge or diverge. We are going to make this one summation n equals 1 to infinity of 1 over n to the 3 halves. And that would be, P would be greater than 1. So by the P series test, summation n equals 1 to infinity 1 over n times the square root of n converges. And B, our P is 1/3. And 1/3 is in between 0 and 1. So by the P series test, summation n equals 1 to infinity 1 over the cube root of n diverges. And on the next one, n is 1/4. I'm sorry, P is 1/4. And 1/4 is between 0 and 1. Therefore, it diverges by the P series test. Now, this is a good one because it's continuous. It's also positive and decreasing. We could use the integral test also. I just wanted to show you that you can do, solve this one both ways. So we could say the integral from 1 to infinity of 1 over the 4th root of x dx, and we would say, okay, the limit as b goes to infinity of integral 1 to b x to the negative 1/4 dx, limit as b goes to infinity, this would be x to the negative 1/4 plus 4/4, so that would be x to the 3/4 divided by 3/4 is multiplication by 4/3 from 1 to b. Limit as b goes to infinity, this would be 4/3 times the 4th root of b to the 3rd power minus 4/3 times 1. Well, this goes to infinity, so this would be infinity and therefore diverges. And so you could, you don't always have to use one test. There are other options. This one is not a P series. This is just 1 over e to the n. So your n is like 1, 2, 3, 4. It doesn't have like a constant. This ends up being a geometric because you can write it like that. So your first term would be 1 over e. And and your r would be 1 over e. So your sum, it does converge because your r is between 0 and 1. Your sum would be 1 over e divided by 1 minus 1 over e. So 1 over e divided by, this would be e over e minus, so this would be e minus 1 all over e, and then multiply by the reciprocal. And it converges to 1 over e minus 1. You could also use integral test on this one. I'm not going to do it though. We'll do it a different time. Maybe we'll come back to it after we do the integral test. And finally, these last two, I am going to use the integral test on this one. So we're going to take the integral from 2 to infinity, 1 over x squared minus 1 dx. And we're going to factor this to x minus 1 times x plus 1 and use your partial fractions. So I know a times x plus 1 plus b times x minus 1 is going to equal 1. If x is 1, then it'll be 2a equals 1. A would be 1/2. If x is negative 1, then negative 2b equals 1, and b will be negative 1/2. And so limit as b goes to infinity, integral 2 to b, this is going to be 1/2 over x minus 1 plus negative 1/2 over x plus 1 dx. Limit as b goes to infinity. This is going to be, I'm going to pull that 1/2 out front. And this is going to be the natural log of x minus 1, of the absolute value of x minus 1, minus, because I still have that negative there, natural log absolute value of x plus 1 from 2 to b. And so we've got 1/2 ln of b minus 1 minus ln of b plus 1 minus ln of 1 minus ln of 3. Oh, sorry about that. So this one, I would probably think of it as b minus 1 over b plus 1, like that. And then this one, it'd be minus a minus 3. This goes to 0, of course. And minus a minus ln 3 would be plus ln 3. And I could put it over 2, just like to distribute that 1/2, okay? But when I put infinity into this, I actually get 0, okay? Because this is b minus 1 over b plus 1. And as b goes to infinity, you actually get the natural log of 1, which goes to 0. And so this becomes, this limit goes to ln 3 over 2. So this converges. And this is considered the upper bound of the summation. Okay, so I'm going to change my color for the last one. And for this one, I'm going to use the integral test. So I'm going to say consider, 3 to infinity, 1 over ln of ln x times x ln x dx. So we'll change this to the limit as b goes to infinity, integral from 3 to b, and we're going to use u substitution, and our u is going to be ln of ln x. Our du is going to be 1 over ln x times 1 over x, because that's the derivative of ln x, dx. So x ln x du is my dx. So this is going to be 1 over u times x ln x times x ln x du. And those cancel. Now, this would be ln of ln 3. This would be ln of ln b, 1 over u du. And ln, absolute value of u, from ln 3 to ln b. And so ln of ln b, that's a lot of ln's, minus ln of ln 3 this goes to infinity. So therefore it diverges. And if this diverges, then the summation diverges.